Hi, this is Involved Innovation YouTube channel. Welcome to the brand new series on Git. In this video, we are going to see why we need version control, key benefits of using version control, two major divisions of version control, one based on topology of the project and another how we represent the versions. So based on the topology, we have centralized version control and decentralized version control. Centralized version control example is SVN, decentralized version control is Git. Based on how we represent version, it is classified into snapshot based version control and delta based version control. And we will also see what is Git and benefits of using Git and introduction to key terminology in Git. This is part 1 of this series. We will cover a lot about Git in the coming videos. If you haven't subscribed till now, try subscribing this channel. That will motivate me to put more videos, and thanks if you have already subscribed. This video is divided into chapters so that you can navigate to any particular chapters with the timestamp. We are going to see why we need version control in the first place and why it is mandatory for a developer to work with version control. Version control is a system that records changes to a file or a set of files over a time so that you can recall specific versions later. Version control is also called as revision control or source control. For example, you are editing an image today and opening it tomorrow and making some more changes. Then you feel like you messed up something today and we want to go back to the previous version which you have saved yesterday. One way to handle this without version control is save each version daily, make a copy of yesterday's version and work on it. This will work well if you have minimal change. And what happens if you are working on a very big project which spans over a year and daily you want to create multiple versions? And one biggest problem is it will become clumsy and data size increases. What if multiple people want to contribute to the same project? This is where we need version control. And provided we are working remote now, the version control tool is mandatory. If you are a graphic or web designer or a software engineer and want to keep every version of image or layout or code base, which you would most certainly want to, a version control is very wise thing to use. It allows you to revert selected files back to a previous state, revert the entire project back to the previous state, compare changes over time, compare between different branches and see who last modified something and that might be causing a problem, who introduced the issue, when, and more. Using a version control also means if you screw things up or lose files, you can easily recover. In addition, you will get all this with a very little overhead. There are lots of benefit if you use version control system. Now we will discuss about some of the key important benefits. First thing is code together. Now in current world, code together is very essential because you are from any part in the world. Version control synchronizes versions and makes sure that your changes don't conflict with other changes from your team members. Your team relies on version control to help resolve and prevent conflicts even when people changes at the same time. So developers can work remotely and still make sure that the changes are not conflicting with each other and they can work on same feature parallelly. If there is a conflict, they can resolve at the earliest stage possible. For example, there are two developers who are working on the same project. One developer commit the initial version to the remote repository, and another developer who can be working from a different geographical area can take this file and modify this file and push it back to the same remote repository. By this way, they can code together on the same code base using this version control tool. Next is versioning. Think the software which you are creating has different versions. In this case, you can easily create multiple branches and that multiple branches can support different versions. So version control allows you to save changes to each version individually and without affecting other version. And you will also work on multiple versions parallelly. You don't need to wait for one version to go to production to work on the different version. Next important thing is keeping a history. Version control tracks the history of changes as your team saves new version of code. This history can be used to find who, when, and why changes are made, and even what changes are made. History gives you the confidence to experiment since you can roll back to any previous good version at any time. History lets your base work from any version of code such as to fix a bug in the previous release. For example, here there are two developers who are working remotely. Each commit made by a developer has the information such as when the commit is made, who did the commit, and descriptive message developer added to the commit, change history, and unique commit hash. We also have some of the very important benefits in today's world, that is CI/CD. Version control automation features, it saves your team time and generate consistent results. Automate unit testing, static code analysis, security vulnerabilities at the earliest stage possible, and deploy when the versions are saved to version control. And you can even set up your own continuous integration and continuous deployment to your code base, so that whenever a user commits to the particular branch, it will be deployed to any environment possible. And you can also automate different tasks whenever a user commits to the repo. Workflow. Version control workflows prevent the chaos of everyone using their own development process with different and incompatible tools. Version control system provides process enforcement and permissions so everyone stays on the same page. For example, let's consider two developers working on a JavaScript project for which they are not using version control. Let's take one using gulp.js to automate time-consuming tasks and another one using grunt to automate time-consuming tasks. Now, when they want to merge their code, they need to use not two but one. So it requires substantial changes to unify the project to same tool. This can be avoided easily if everyone is using version control from the day one. And version control avoids this kind of conflict. Next, we will see about two major divisions of version control. There are two major divisions, one based on the topology of project and another based on how we represent the versions. Based on topology, it is divided into centralized version control and decentralized version control. Centralized version control systems are based on the idea that there is a single central copy of your project somewhere, probably on the server, and programmers will commit their changes to the central copy. Committing a change simply means recording the change in the central system. Other programmers can see this change. Here, checkout means taking the latest version of code from the central server, and history will be always preserved in the server only. If server data gets corrupt, the user cannot get the history of files. Example of centralized version control systems are SVN and CVS. People are not using centralized version control system much. People have moved towards decentralized. There are some legacy applications still using SVN. So understanding SVN also vital if we are supporting a legacy project. Next, we will see about decentralized version control. Decentralized version control system do not necessarily rely on a central server to store all the versions of a project file. Instead, every developer machine clones a copy of a repository and has the full history of the project on their own hard drive. This copy or clone has all the metadata of the original. The act of getting new changes from a repository is usually called pull, and the act of moving your code changes to this repository is push. In both cases, you move change sets, that is, changes to file groups as a coherent wholes, not single file difference. Advantages of using decentralized version control. Performing actions other than push and pull change sets is extremely fast because the tool only needs to access the hard drive, not the remote server. So for push and pull, you need active internet connection. If the server is down or server data get deleted, the developer will have the history of files in the local. One developer can clone a version from other developer since he have history of files in their hardware. Examples of decentralized version control systems are Git and Mercurial. Now we will see, based on how we represent the version, it is divided into Delta based version control system and Snapshot based version control system. Delta based version control system store information as list of file based changes. This system thinks information they store as a set of files and changes made to each file over time. This is commonly described as Delta based version control. So we will see this with an example. Here I am creating a file named test.xml. I am committing this test.xml for the first time, so this is an initial version. First, it stores the complete test.xml file I am committing again without doing any modification to the test.xml. This will be stored as the version 2. In the version 2, no code changes are stored. Now I made some changes to the test.xml and committing it again. Now it is stored as version 2. Only the modified information is stored here. 36 got replaced with 40, so it stored the delta as 36 as deleted and 40 as added. And I added React and Git to the content, so it is stored the delta as IoT Python React Git as newly added and IoT Python got deleted. In the delta based version control, not storing the full file, only the changes are stored as the delta. Now if I rename the file test.xml to test_rn.xml, it will be stored as file rename and this will point to the original test.xml. What is snapshot based version control? This system thinks of its data more like a series of snapshots of a miniature file system. With snapshot based version control, every time you commit or save the state of your project, it basically takes the picture of what all your files look like at that moment and stores a reference to that snapshot. To be efficient, if the files have not changed, it does not store the file again. Just a link to the previous identical file it has already stored. Git thinks about its data more like a stream of snapshots. We will see this with the example. Here we have the same test.xml and I am committing its initial version. Here it got saved as complete file with a unique hash code. For the sake of simplicity, let's take the commit hash as x8n. So this is the hash code. Here x8n hash key holds the complete file information. I am committing the test.xml again without doing any modification. So now in the version 2, we have same commit hash for the file which refers to the initial version of the file. I am committing another version by adding some modification to the text.xml. Now this will store the complete file with a new hash code. This is the main difference between snapshot based version control versus delta based version control. As we seen in the delta based version control, this got saved as a delta file difference, whereas here in the snapshot based version control it is saved as a complete file with a different hash code representing this commit. If we rename this file from test.xml to test_rn.xml, the file got renamed but it still points to the previous commit hash. If you are familiar with Git, you find some discrepancies here with the file name. We will cover more about this when we discuss git mv command in the coming videos. Next we will see why we need Git. Git is the most commonly used version control system today. Git is mature, actively maintained open source project originally developed in 2005 by Linus Torvalds, the famous creator of the Linux operating system kernel. A staggering number of software projects rely on Git version control system. You may be very familiar with GitHub, GitLab, Bitbucket, all those are relied on Git technology, including commercial projects as well as open source. These are important benefits of using Git. Git is a distributed source control system and snapshot-based version control system. Git does not necessarily rely on central server to store all the versions of a project's files. Instead, every developer clones a copy of a repository and has a full history of the project on their own hard drive. Git scales massively. Because of the distributed nature of Git, it can scale massively. Git is initially developed for Linux project requirements. Today, Linux kernel has over 15 million lines of code and more than 1,200 developers across the globe. And Git is free and open source. There are many commercial projects which are based on Git, and you can also find free and open source systems which are based on Git. One great example is GitHub. Because of its distributed nature, most operations in the Git are local, so you might not need active internet connection most often. Git has a very active community and it is evolving day by day. It has already become mature, but it is evolving day by day, so that most of the answers which you are looking for is already answered by someone. So it has a very active community and you can find answers to every problem you face. Now we will see about some of the key terminologies and basics about Git. Every time you save your work, Git creates a commit. A commit is a snapshot of all your files at a point in time. If a file has not changed from one commit to the next, Git uses a previously stored file. Commits create links to other commits, forming a graph of your development history. You can revert your code to the previous commit, inspect how files changed from one commit to the next, and review information such as where and when changes were made. Commits are identified in Git by a unique cryptographic hash of the contents of the commit. Because everything is hashed, it is impossible to make changes and lose information or corrupt files without Git detecting it. Each developer saves changes to their own local code repository. As a result, you can have different changes based off the same commit. Git provides tools for isolating changes and later merging them back together. A branch in Git is simply a lightweight movable pointer. A default branch name in Git is master, but this is completely customizable. As you initially make commits, you are given a master branch that points to the last commit you made. Every time you commit, it moves forward automatically. Branches, which are lightweight pointers, which is created for each and every feature, are epic. Once your feature or epic is completed and you have tested that feature, then you can move that branch to the team main branch. So here, branches will be created for individual developers. So if the developer works on a particular feature, he or she will create a branch tagging that particular feature. Once that feature is done, he or she can merge it back to the master branch. Files in Git can be in one of the three stages. One is working directory, next is staging area, and the third is the remote repository. When you first modify a file, the changes exist only in the working directory. They are not yet part of the commit or your development history. Here I have created three files, a HTML, a CSS, and an image file in this working directory. You must stage the files you want to include in your next commit. Here you can do that by using the command git add and pointing to the files you want to add to the staging area. And you can even omit files that you wish to commit separately by doing add with one file, and then you can commit, and you can add another file, and then you can commit. Here I want to stage only the CSS and image file so that it will be included in the next commit. The staging area contains all the changes that you will include in our next commit. Once you are happy with the staged files, commit them with a message describing what changed. This commit message might be really important because this may be served as a documentation for you and your teammates. This commit becomes a part of your development history. Here when I hit the commit, the staged CSS and image file got committed. Here everything happens in local, so it does not require an active internet connection. If you are from a SVN background or centralized repository background, then their commit is different and here the commit is different. In SVN world, if you commit, that means you are pushing to the central repository. But here, if you commit, you are pushing only to the local repository. You are not pushing to the centralized global repository or the remote repository. So all the operations can be done offline here. Once you are finally okay with the changes, you can push the local commits to the remote repository. This is when you need an active internet connection because you are trying to contact the remote repository. I believe you have learned a lot in the first part of this Git series. Subscribe to this channel for more videos on Git and hit like if you have enjoyed this content and share it with your friends. Thanks for subscribing and watching this video.